Hello, this is Susie Newhan, and this is the fourth in our series on linear functions. This is the one about changing the subject of a function. So if we have price as a function of quantity, we can rearrange it so that quantity is a function of price. Let's look at a function. This one. We've already seen what it graphs like. We know Q is going to be there and P is going to be there. Yeah? The independent variable is always on the horizontal. And so when we've got Q equals, we know Q is always the one up here. If we know the value of P, we can read off the value of Q quite easily. Now we know it's going to cross the Q axis at 4. Here it is, 4, and we know this is a gradient, so we know it's going to be very shallow. So let's just draw it in a sort of shallow looking way. And we know that the slope equals a half. So the task for today is to rearrange it so that we can plot it and also understand it in the form of P as a function of Q. So let's remind ourselves that here Q is a function of P, and here P will be a function of Q. Now this might be a supply curve. This would be an inverse supply curve. But I don't need to go into too much of that at the moment, but just to let you know, it's showing you the same information, but it's showing you in a different way. And economists like to do this because it gives insights in different contexts. So how do we rearrange this function so that we can now plot it on that graph? Because it's all wrong at the moment. So this is where we use the algebra, the basic algebra we've been learning. And this is rather like solving for P. We want to end up with P equals. So we want to get P all on its own on this side of the equation. So how do we get rid of that 4? Because that's really getting in our way there, isn't it? Well, we're going to subtract 4 from both sides. So here we go. Q minus 4 equals a half P. So we're getting closer to P being all on its own. But at the moment, we know what half P is, but we want to know what a whole P is. So hopefully, you can see that if we multiply both sides by 2, we will get a whole P there, which is just what we want. And here, we've got to multiply every term on this side by 2. 2Q minus 8. So there we have it. Let's rewrite it because we like the dependent variable to be on the right. And I'm going to use the way the economists tend to write linear functions. I'm going to put the constant first. And there's our function. So we have rearranged it. We've made P as a function of Q, and now we can plot it on our graph. Oh, but hey, look, let's say this is 5, 10, minus 5, minus 10. But this one starts at minus 8, so we need to start about here. And it's steeper. It's got a gradient of 2, so it's going to come more upright. Slope equals 2. In fact, the gradient of this will always be the inverse of the other function. So there we've done it. We've achieved what we're going to do. We've rearranged equation and plotted a new one. So I'll do another one, and then you can practice yourself. So let's look at another function. P equals 9 minus 3Q. So this time P is on the vertical axis. And this one is going to cross the vertical axis at 9. But what do we notice about the gradient? It is a negative, so it's a downward facing one. So it's coming down. Yeah, fairly steep, so minus 3. So that's what that one looks like. But we want to say, take it to the in the form where Q is a function of P. So this is Q function of P, this is P as a function of Q, which means that we need to rearrange that as we did the other one. So let's write that again. So what this means is we want to make Q the subject of the equation. So we want to get Q all on its own. But one of the things we learn in algebra is that if we're trying to solve for Q, we really don't like the fact that Q is negative. So best practice algebra, we should always make the important variable positive first. So I'm going to do something odd, which might seem odd. I'm going to take it to the other side and make it positive. You don't have to do this. I'm just showing you the way. So what I'm going to do is I'm going to add 3Q to both sides. So what happens then? I'm going to get P plus 3Q equals 9. So now, remember I'm trying to get Q all on its own. So now I need to get rid of the P. If I get P to the other side, I'm most of the way there in making Q the subject. So what am I going to do? I'm going to subtract P. So what will that look like? So we now know what 3Q equals, but we're not interested in 3Q, we're interested in a single Q. So what we need to do is to divide both sides by 3. 3Q divided by 3 is a single Q, which is of course what we want, but we also now have to divide everything on this side by 3. So it's going to be 3 minus. Now I can either write P over 3 or I could write it as 1/3 P. They're both mathematically equivalent, but I'm going to use this form just because it's sort of a more convenient way to look at the gradient. But they are exactly the same. When we multiply a fraction by a number, we multiply just the top row of the fraction, so it would end up as 1P. It would look just like that. Let's take that off. So we've done what we've set out to do. We've put Q as a function of P. We can now sketch it. So we know it's going to cross at 3. It's a negative slope, but quite a shallow one. So it's going to look a bit like this. Minus 1/3. This is, because it's downward facing, downward leaning, it's a demand function. On the previous bit, I said curve. I really meant function. They become curves later on, but for now we can just deal with straight lines. And this is a demand function. But it turns out that this one is an inverse demand function. But they tell you the same information. It's the same function, it's just displayed differently. And much more on that later. So here's some rearrangements for you to try yourself. For each of them, sketch them first because it's good practice, and then do the change of subject and sketch it again. I will show the sketch answers after this, and for those who struggle, stay on the video and I'll go through the examples myself. Good luck. Okay, let's just run through these. Here's the first two. Right, so I've sketched it already. So it starts at 1, it's got a slope of +2, so it's going upright. So how do we make Q the subject of this? Well, that means we want to get Q all on its own. So let's start by subtracting 1. If we get 1 out of there, we start getting Q on its own. So I subtract 1 from both sides. And I get that, so we're almost there actually, aren't we? So we know what 2Q is, but what we're really interested in is what 1Q is. So if we divide both sides by 2, we'll get a single Q on that side, which is what we want. So dividing by 2, well, this should have been a division sign here, whoops. Divide that by 2, we get a single Q. And then I have to divide everything on the other side by 2. So I'm going to get a half P minus a half. So I've halved everything. So let's write it out in the way we normally do. So Q equals minus a half plus a half P. P. So what does that look like? That's now got Q on this and P on that axis. It's crossing the y axis at -0.5, and it's got a very shallow gradient. So slope equals 0.5, and there it is going through at -0.5. Right, what about this one? Yeah, that intercepts the vertical axis at 6, and it's got a slope of -2, which means it's downward. We can tell it's a negative slope because it's coming down. From there to there, the Q value didn't increase, it decreased. So it must be going down. So we want to make P the subject. Here, the important variable P is negative. So best practice algebra tells us we should move it to the other side. And how do we move it to the other side? Well, we add 2P to both sides. As I said, you don't have to do it this way, but this is the way we're taught in school. All right, so now we want to get P all on its own, so we need to get rid of Q now. Yeah, how did we get rid of Q from that side? Well, we subtracted Q from both sides. Yeah, so it disappeared from there and arrived here with a different sign. And now we're almost there. Now we just need to divide by 2 so that we get a single P. Need to divide both of these things by 2, so I get 3 minus 1/2 Q. So there we are. So this now looks like we've got P, we've got Q, it crosses at 3, and it has a very shallow but negative gradient. So there's it going off like that. Right, let's look at the last two. So here's P, 3 plus 2/3 Q. Yep, gradient of 2/3 crosses the P-intercept at 3. Let's rearrange it, make Q the subject. So what do we want to do? Well, we want to get 3 over to the other side, don't we? So we are going to take away 3 from both sides because we want to get Q all on its own. Right, now, there's lots of ways of doing this, but the simplest, most straightforward way is to say, right, if we multiply both sides by 3, whoops, if we multiply both sides by 3 first, we'll get rid of this fraction here. And let's see what that looks like. So we're going to multiply both sides by 3, which is a technique we do to get rid of a fraction, or to simplify a fraction. So we're going to multiply everything on this side by 3. Multiply 2/3 by 3, we just get 2. Now the 3 we're multiplying by cancels out with that 3 on the bottom. So now we just need to divide by 2, and we've got a function of Q that we wanted. But we need to divide everything on this side by 2 as well. So 3 over 2P minus 9 over 2 equals Q. So there's our function. Q equals minus 9 over 2 plus 3 over 2P. Put them in that order. The order doesn't matter, as we've discussed. All right, so what does that look like now? Well, we can graph that. Let me do it in a different colour. We've now got Q on the vertical and P on the horizontal axis. Oh, we can see that it's going to starting at minus 9 over 2. That's where it's going to cross the vertical axis. It's got a positive gradient of 3 over 2, which is like 1.5. So let's say it's something like that. So a slope equals 3 over 2, crossing the axes at 9 over 2. All right, how about this one? Right, so we want to put it in terms of P, but we notice P is negative, so best practice tells us let's make that bit positive first. Okay, so what did I do? I added 3 over 5 to both sides. Now I want to get the q over to the other side because I'm trying to isolate p on this side. I'm trying to make p the subject. So I'm now going to subtract q, and that will leave me now. If I multiply out by 5, I get rid of this sort of troublesome fraction on that side. So let's multiply both sides by 5. If I multiply this by 5, the 5's cancel out. If in doubt, you can always do that on your calculator. So I'm multiplying every term by 5. So we're almost there. It's just we've got a function for 3p, but we want a function for 1p. So what am I going to do? I'm going to divide by 3. So there's our function. We can plot that. It's now p and q. It crosses the p axis at 5. It's got a negative slope, so it's going to come down. It's going to be steeper than that one, because 5/3 is a bigger number than 3/5, so it's steeper, equals minus 5/3. Okay, hope that was helpful.